Greetings, welcome to the problem 3.27 Underage Drinking Part 2. We learned in exercise 3.25 that about 69.7% of 18 to 20-year-olds consume alcohol beverages in 2008. We now consider a random sample of 50 18 to 20-year-olds. How many of our random sample of 15 to 18 20-year-olds would you expect to have consumed alcoholic beverages round to 1 decimal place? What is the standard deviation round to 2 decimal places? Okay, so in order to be able to answer these questions, we've got to remember a couple of things real quick. This situation, again, is the binomial situation. Okay, either they drink or they don't. The trials are independent. There's a fixed number of trials, and the probability of success remains fixed in each one of them. Okay, so that's our FAB4 for determining whether it's binomial. So here we're going to be given that n was equal to 50, and the probability of success, p. What was the probability of success again? Let's remind ourselves real quick. Let's see, what was it again? It was 69.7%, okay? So that's 0.697. So 0.697 is our probability of success. Okay, a couple other things we need to know is that if you're given a binomial random variable, in other words, ours is n by p, 50 by 0.697, then you know the mean or the expected value. That's a key word there. When you see what would you expect, you should be thinking the mean there. That's equal to n times p. And then the standard deviation of a binomial random variable is given by the square root of n times p times 1 minus p. So many books, ours included, many times will refer to q is equal to 1 minus p. Okay, so keep that in mind. If you see n times p times q, if I do that by chance, that's what the was intended there. Okay, so we're going to go ahead and do that. We're going to go ahead and do these calculations. So let's go ahead and find out what mu is. So mu is going to be equal to 50 times 0.697. Okay, so I don't think I can do that in my head, so let's go grab my calculator here real quick. So let's finish putting that on there. Okay, so calculator, we're going to go 50 times 0.697. Hit an enter and we get back 34.85. Okay, they said round to the nearest decimal place. So that would be what? Approximately equal to 34 point, let's see, what was it again one more time. Let's get back to the calculator here. 34.9 if we round out to one place. Okay, how do we calculate the standard deviation? Well, sigma would be equal to the square root of n times p times 1 minus p. So that's going to be n. I'm going to put the actual number in there. Let's put 50 in. Times p. Let's see, what was p here? Well, that's 0.697 times 1 minus 0.697. All right, now it takes a little bit of practice to get good at putting this in our calculator. Not too much, but enough to warrant taking some time to do it here. Okay, so let's see, how do we put that in the calculator? We're going to go second square gets me the square root. Now, if you're in an older calculator, it opened it with a parenthesis here. It's going to be very important at the end that we close that parenthesis to make sure the calculator understands what we want in the square root and what we don't. If you're in a newer model like this one, it's just going to stretch the bar across for us and let us know what's in and what's not. Okay, so let's go ahead and just type it in the way we put it in there. So we wrote it down. So parentheses 50, parentheses 0.697, parentheses 1, subtract 0.697, close parenthesis, and then like I said, if you're on an older calculator, close the parenthesis again. Oh, look at that, I made a mistake. I forgot the other close parenthesis there. It's going to blow up. To get that other close parenthesis in, it's kind of a fortuitous sort of mistake. I can show you how to edit this. I would get right here and I would hit second insert. The calculator comes stock in type over mode. If you want to insert something, you've got to tell it to insert it by hitting second delete to get into insert mode. That was good. It was kind of a nice little thing. Okay, so what do we get here? We get 3.25 for our standard deviation. So sigma here is equal to 3.25. I'm sure I rounded off correctly here. Let me just check that real quick. Yeah, 3.25. Okay, cool beans. All right, so that answers our first two questions. Here, let's come back into the slide here, get a fresh page here, and let's go ahead and see. So what was the mean and the standard deviation? So let's see, what was the mean? Go back to our calculator for a second. The mean was, oh heck, I'll just go back to this previous slide. We'll do it that way. The mean was what, 34.9? And the standard deviation was 3.25. All right, cool. So now what? All right, so now would you be surprised if there were 45 or more people who had consumed alcoholic beverages? All right. Well, how would we do that? How would you decide that? Well, one thing to realize is that we can use the normal approximation idea to the binomial, provided that n times p and n times q are both greater than or equal to 10. Okay, so we've checked n times p here. Let's go do a quick check on n times q just to make sure that we're on safe footing here. So n times q would be what? It'd be 50 times 1 minus 0.697. And that comes out to 15.15. So that's also greater than 10. So we're on safe ground to go ahead and use the normal approximation. We'll actually need that more in part C than we're going to need that here in part B. But thinking ahead just a bit, what we're going to do is we're going to come in and we're going to calculate a z-score here. Okay, now why? Well, because we know that by the 68, 95, 99.7 rule, or the empirical rule, that most of our data in an approximately normal distribution should reside within 2 standard deviations of the mean, 95% of it. If you're more than 2 standard deviations above or below the mean, then you're probably an unusual event. And what z does, really this is really the only formula you really should memorize here, is what z does is it gives you the number of standard deviations your data point falls above or below the mean. So that's a really important formula. You should probably get that tattooed if you're planning on getting any new ink this week. You know, do it in henna, whatever. That's something you need to definitely memorize. Okay, so let's calculate the z-score for our Intrepid 45. We want to see that. All right, so that tells us z is equal to 45 minus, what did we come up with, mu? Remember, this is mu right here, and this is sigma right here from our previous calculation. So that's going to be what? Minus 34.9 and divided by 3.25. Now, I'm not going to do that calculation for you. I'm going to let you do it, but keep in mind the calculator needs parentheses for the numerator. It doesn't have a long fraction bar. So make sure you wrap that numerator in parentheses before you do the division. If you don't, you're going to get the wrong number, okay? And now you take a look at it and you decide, is z an absolute value? Is it greater than 2? If it is, then that would be surprising. I would be surprised to see 45, okay? All right, so last one down here. What is the probability of 45 or more people in the sample have consumed alcoholic beverages? Okay, so again, like I started to say, we're going to go ahead and use the normal approximation to the binomial here to do that calculation. Nope, changed my mind. We're not going to do that. We're going to go ahead and just use the binomial for it. My bad. Sorry about that. I just remembered the testing system actually didn't use the normal approximation here, so we'll get the wrong answer if I do it that way. So don't do that. Sorry about that, but some days chicken, some days feathers. Okay, so we know that it's what? It's binomial n times p, or n by p, excuse me, gives me my binomial distribution. So what was our n here? Our n is 50, and our probability of success is 0.697. Okay, so they want to know 45 or more. So again, do a number line. Always do a number line when you're working with the binomial, okay? So you got one of them was drinking, two of them was drinking, three of them was drinking, dot, 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 all the way up to 50. Because remember, our sample size here, n, was 50, all right? And what we want is 45 or more, okay? So that's 45, 46, dot, 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 all the way up to 50. So these are all of the points that we want, okay? So we want to know that. So what is the probability that X is greater than or equal to 45? That's the question, okay? Now remember, we've talked about this before. It's a little tricky, but it's not horrible. What I need to do is I need to get these green probabilities also, okay? So all these here, all right? And those green probabilities, what are those? Those are the probabilities that X is less than or equal to 44. And if I add those two together, if I sum those up, those have to add to 1. Now the reason I need that is because remember, our calculator always sums up with binom CDF from the left. Okay, so let's get a fresh page here so that we can work on a fresh page, okay? All right, so we've got the binomial probability of X being less than or equal to 44 plus the binomial probability of X being greater than or equal to 45 adds to 1, okay? So the one we want is this one. So to get that, we're going to solve this equation for that. So that's going to be the binomial probability, yes, we're going to solve for that. So the binomial probability of X being greater than or equal to 45 is equal to 1 minus the probability of X being less than or equal to 44. All right, cool beans. Now, why did we solve for that? Because the calculator can do this one for us. So to do that, we're going to take 1 minus binom CDF. I'm going to put in a 44. Then we're going to put in n, which was 50. And then we're going to put in the standard deviation, which is 0.697. Okay? All right, and what you're going to find is that's going to be a pretty small number. So the probability of X being greater than or equal to 45 is going to be relatively small. So what that tells you, comparing that to the previous answer, is you were a lot of standard deviations away from the mean. There was not a lot of probability mass left, which is demonstrated by calculating this probability. And therefore, you would say, I would be rather surprised if I got more than 45 drinkers in a sample of 50. Okay, well, hopefully that is enough to get you going. Like I said, I'm not going to do the calculations here. You get to do that part. I don't want to give you the answers. That's just, taking too much fun away from you. So be sure and post to the Q&A forum if you need additional help.